Hey, what's up, guys? This is Cheng here. So let's take a look at today's daily challenge problem, number 991, broken calculator. This one is very interesting. Like I would call it a math problem. So basically, you're given like a broken calculator that can only do two operations. So you can only do double the numbers by two, or you can decrease the numbers uh, by 1, right? And then you're given like the x and y, and you need to return the minimum number of operations you needed to this to change the number from x to y. Okay, so example 1 here, right? So we have 2 and 3, so that's why the answer is 2, because we doubled x to 2 to 4, and then we decrease by 1, right? And then here are a bunch of other examples here, right? Yeah, and note the number range is 10 to the power of 9. So this one means that, actually the naive approach will be we just do a basically a search, right? So at each of the locations, let's say for x, right, we can either do a double or we can do a decrease, right? Basically for each of the step, you try both two scenarios. But given like this huge number, 10 to the power of 9, a simple search will not work. Then how can we solve it, right? So I mean, basically, we should consider like a recursive functions, recursive call. Basically, what does it mean? It means that we have double and decrease, right? So if the y, let's say if the y is odd number, right? So if the y is odd number, to be able to change to y, to the y, the last step must be a decrement, right? Basically, if the y uh, is odd, right? If the y is odd, it means that the last step has to be a decrease, because there's no way you can get to an odd number by doubling the previous number, right? That's why when the y is equal to its odd numbers, the basically it has to be the previous step, right? So the previous step has to be x and y plus 1, right? So that we can use the decrease to change. So why we recursive to x to y plus 1, right? So let's say we have x and y, right? So we have x, and then we have y. So the x, we basically the x will do a lot of multiply by 2 and decrement by 1, right? So it could be a multiply 2, multiply 2, right? And then minus 1, multiply 2, multiply 2, right? And then we have few minus 1 maybe, right? And then in the end we'll have y, right? So basically, we are trying to recursively calculate these steps here. Basically, let's say if the y is equal to is odd, it means that the last step has to be a, a decrease, right? A subtract. So which means that uh, before the first before this last step. So what was the previous step? So the previous step is the left side is still x, but the right side, right? So if we move this part to here, right? So we'll have y plus 1, right? That's why we have this y plus 1 as the as a previous step. And similarly, right, if the y is even, so we'll have like x dot y divided by 2. So which means that the if the y is even, the last step it's always going to be uh, the the multiply the double one, right? And so why is that? Because it could be it could also be basically we are two scenarios. So the first scenario is that we have some like a multiple a double in the end, right? Equals to y here, right? And the other one is that we could have like some minus minus minus, right? To the end, equals to y when the y is like when the y is the empty. Sorry, is the even. So I think it's pretty straight. It's not that hard to prove that the double is always better than the minus as the last few steps. And why is that? Let's say we have let's say in the end we have let's say we have eight let's say we have 8 ones in total. We have eight we have 8 ones in total, right? And before that we have like a double two here, right? So and then basically, so what formula we have? We have 2 times x, right, minus 8, right? So that's the formula. But if we abstract 2 out, what we have? We have 2 times x minus 4, right? So what does it means? It means that if we have a double and then followed by 8 minors, it's this one basically how many steps operations we have. So here we have 9 operations, right? So 2x minus 8, right? But if we do it in this way, right? So if we do a x minus 2 first and then we do a double, right? So how many operations we have? We only need 5 operations in this case, right? So basically, it means that we can use x to double minus 1 to decrement 4 times, and then we do a double. It's equivalent to basically to do a double and then do a 8 decrement, right? So which means that if the when the y is like even, the last step should always be this kind of uh, double, right? So which means that if we move this part to here, we have this kind of y divided by 2, right? So now I think it's kind of clear that we have already figured out all the best scenarios uh, for each of the recursive call. So I think the rest is just like the implementation. So if the first is the exit point, right? So if the x is greater than y, right, we simply return the x minus y, right? So which means that if x is greater than y for this case, right? So we have to basically we have to always do the decrease of x until it's equals to y. There's no way we can double x anymore. So that's why we just simply return x minus y. Else, right? So if the y is like it's an odd number, right? So it means that the previous step, the next step, right? It's basically the x dot y plus 1, and then we do a plus 1 because that's the plus 1 means the current operation, right? So after the current operations, the remaining is the is y plus 1, right? The else is going to be return dot self dot broken calculator x dot y divided by 2, and then we do a plus 1. So here, basically, I think it's as if we're trying to reduce y to x, right? Yeah. So if I run the code here, accept it. Yeah. So I mean, for the time complexity, right? I mean, since we're going to continuously divide y by 2, so it's going to be a log y, right? But we stop until y is smaller than x, so I think this one should be y minus x. Uh, yeah, so or it could be some similar to log y here. Mm. Well, actually, I think should be y divided by x. Yeah, I think that's the time complexity. Hmm. Yep. So I think that's it for this problem. You know, the basically the trick here for is that we think it backwards, right? In the reverse order. Basically, we're thinking it as if we're trying to remove uh basically changing y to x, right? And then with with either the odd or the even, we take one of the two scenarios, and then we just do it recursively until the y is smaller than x. Then we simply just return that. Cool. I think I would stop here. Thank you for watching the video, guys. Stay tuned. See you guys soon. Bye bye.